All right, I'm going to keep using the intermediate value theorem. Here's my next example. It says, explain why an x-intercept must exist between x equals 5 and x equals 6 for the function y equals x to the fourth minus 6x cubed plus 7x squared minus 30x plus 10. Big, long function, kind of ugly, but let's work on it. So, the intermediate value theorem says that first off, I have to have a function, boom, got it, that is continuous. Now, hopefully you guys realize x to the fourth, x cubed, x squared, x, and 10. That is a polynomial. And polynomials are continuous everywhere. So it doesn't matter what numbers I use, that sucker's continuous. So let's keep going. Again, intermediate value theorem. Function has to be continuous from A to B. Well, over here we've got A and B. X equals 5 is my A. X equals 6 is my B. Again, let me repeat one more time. A and B are x values. Now, let's keep going. So, we've got this function. It's continuous everywhere, including x equals 5 to x equals 6. Now, the next part that I need to worry about is the y value stuff. So, let me go ahead and start working on that. What I'm looking for here is an x-intercept. Now, let me just make sure I mention this to you. In case you did not already know, x-intercepts happen when y equals 0. So that's actually going to be my n value. I'm using n as 0. So what I want to check, just to be sure, because this is going to be the important part, is that f of a and f of b, if I plug in 5 and 6, I should get numbers bigger and smaller than 0. So let's find out and let's see what happens. So here I go. I'm going to plug in 5. So we're going to do 5 to the fourth minus 6 times 5 cubed plus 7 times 5 squared minus 30 times 5 plus 10. All right, let's go ahead and start trying to do some math. All right, now I'm going to come over here and I'm going to grab my calculator. Let's do this. So 5 to the fourth gives me a whopping 625. Then I'm going to do 6 times 5 cubed. All right, that gives me 750. Then I'm going to do 7 times 5 squared. All right, that gives me 175. Then I'm going to do 30 times 5, which I know is 150, plus 10. Now I'm going to go ahead and start trying to combine stuff, all right? So 625 minus 750 plus 175 minus 150 plus 10. And I kind of missed a number in here, and I'm going to hopefully make sure I do it right. Let me go ahead. 625 minus 750 plus 175 minus 150 plus 10. All right. I got negative 90. So when I plugged in 5 into my function, I got negative 90. Let me go ahead and do the other one now. I got to plug in 6 and see what happens. You guys ready? So here I go. 6 to the fourth minus 6 times 6 cubed plus 7 times 6 squared minus 30 times 6 plus 10. All right. I'm going to grab my calculator again because I'm going to need it. 6 to the fourth gives me 1296. I know that that's going to also be 1296. That's technically 6 to the fourth. 7 times 6 squared makes 252. 30 times 6 makes 180, which I knew off the top of my head. I don't know why I typed it in the calculator. Again, I know these cancel, so I'm at 252 minus 180 plus 10 makes 82. Now, I'm going to point out to you, because this is really important. Did you notice that we got a negative answer, negative 90, and a positive answer, 82? That means that somewhere between my negative answer and my positive answer has to be 0. It's continuous. It's going to go all the way from negative 90 up to 82. I'm guaranteed to have at least one x value in there that works. So that's the intermediate value theorem again, one more time. I have to have a continuous function from A, x value, to B, x value. I'm going to plug both of those numbers in. And my answer, I'm always going to have one number that makes something between f of A and f of B. So there's always going to be something in here that makes something between negative 90 and positive 82. Now, does it have to be 0? No, I could have picked any number between negative 90 and 82, and I would have known that there's at least one number in there that works. So that's the intermediate value theorem. Again, I'm going to come back and do some more examples.